Welcome to Algebra 1, Chapter 7, Section 5, Rational Exponents and Radicals. As a review, let's write the simplified form of each square root expression. The square root of 16 is plus or minus 4. 4 times 4 is 16, and negative 4 times negative 4 is 16. Square root of negative 100, well, you can't do the square root of a negative number. But if you really want to simplify this, what you could do is you could do square root of 100 times the square root of negative 1. The square root of 100 is 10. The square root of negative 1 is actually non-existent, so we call it an imaginary number. Yep, that's right. We actually call it the imaginary number. And we refer to it as I. So this would be 10I. For number 3, the square root of 169 is plus or minus 13. And problem number 4, in the expression 2 to the third, the number 3 is the exponent. The number 2 is the base. And for our vocabulary, we are going to look at the word index. The index of the radical gives the degree of the root. So the cube root has an index of 3. If there is no index, the degree is 2. In our example, we have the fourth root of 16. So the index is 4. It's this number right here. So ask yourself, what number times itself 4 times is 16? And obviously, 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is plus or minus 2. In using our vocabulary, we're going to circle the index of each radical expression. The fifth root of 32, the index is 5. Cube root of 27, the index is 3. And in the fourth root of 256, the index is 4. And now we're going to write the cube of each number. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4, which is 16, times 4, which is 64. And 5 cubed is 5 times 5, which is 25, times 5, which is 125. So for each of the following statements, write T for true or F for false. The index of the square root of 3x to the fourth is 2. That is true. If nothing is stated here, we assume that to be 2. The degree of a cube root is 4. That is false. The degree of a cube root is 3. So this is false as it's written. The expression, the fourth root of 625, means what number times itself 4 times is 625. That is true. Let's see how well we understand this. To evaluate the cube root of 27, you need to find 3 equal factors of 27. So what times itself again equals 27? So 27 is 3 times 3 times 3. So the cubed root of that is one of those. So the simplified form of the cube root of 27 is 3. Let's do it for each of the following. 32. What times itself times itself times itself times itself equals 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the cube root of 32 is 2. Now let's find the cube root of 64. Well, 64 is 4 times 4 times 4. Now take a look for a minute at this. That's a new way of showing you the cube root. When a fraction is in the exponent spot, it actually means use a radical. It means use the root of. So the cube root of 64 is 4. To restate this new piece of information, a radical can also be written as a rational exponent, which means it can be written as a fraction. So a to the 1 over n is equal to, or the same as saying, the nth root of a. You can also look at rational exponents that have a numerator other than 1. For example, if you have some number a raised to the m over n, your n becomes the index of your radical, whereas your m becomes the exponent inside the radical. Let's check our understanding. So looking at a, b, and c here, We're going to underline the correct words to complete the sentence. The numerator or denominator of the rational exponent is the index of the radical. The denominator is the index. The numerator will be the exponent of the radicand. So it's the exponent inside the radical. So looking at 21, a to the 1/6 means the 6th root of a. X to the 1/3 means, are you thinking about it? It's the 3rd root of x. Y to the 1/3 is the 3rd root of y. So as you can see in problem 24, this 5 is inside. That's because it's the exponent of the radicand. The 6 is the index. In this case, the 3 is the index, and look at this one, it's a bit tricky. This 1/3 only applies to the x, as you can see. It only applies to what's immediately in front of it. Let's take a look at this interesting problem. 54y to the 2/3. Now that 2/3 applies to everything inside the parentheses. But 54 is not a cube. Nothing times itself goes into 54. But we know 27 goes into 54 2 times, and it is a cube. So let's take 27 times 2y. So we're going to have 27. Remember, this applies to everything inside, to the 2/3 times 2y to the 2/3. Well, 27 is actually 3 cubed. So that's 3 cubed to the 2/3 times 2y to the 2/3. These two will undo each other. Cancel here and cancel here. So I'm left with 3 squared times 2y to the 2/3. Well, 3 squared is 9. So that's 9 to the 1st power. And then we have 2y. We're going to have it cubed. There needs to be a 3 there because that applies to this radicand. 2y squared. So 54y to the 2/3 is 9 to the cube root of 2y squared. Let's work to write each radical expression in the exponential form. So looking at the cube root of s squared. So here we have the index. Our index is 3, and the exponent of the radicand is 2. So another way of writing this would be s to the 2/3. In the next one, we have 12 times the cube root of x to the 4th. Our index is cubed, and the exponent is 4. So another way of writing this would be 12 times x to the 4/3. In the next problem, we have the square root of 4y to the 5th. Now this 5 only applies to that y. That's what that parentheses means. So our index is 2, and our exponent of the radicand is 5, but only of that 5. So we would have 4 to the 1/2, y to the 5/2. The index of the radicand is going to be the denominator of the rational exponent. And the exponent of the radicand is the numerator of the rational exponent. You saw this on the previous page where we worked through each of these. To simplify this quite a bit, this becomes the numerator, 2, and this becomes the index becomes the denominator. In the next problem, 4 becomes it's the exponent, so it becomes the numerator, and the 3 is the index, so it becomes the denominator. And in the last problem, this is slightly different than what you saw on the previous page, but 5 becomes the numerator, and 2 becomes the denominator. So what number multiplied by itself 4 times has a product of 256? That is 4. Circle the expression that shows the 4th root of a to the 8th written in exponential form. Remember, this will be your numerator, and this will be your denominator. So this would be the answer. So if we want to write the fourth root of 256a to the eighth in exponential form, we could write it as 4a to the 8 over 4. But did you know those fractions that we're now having, that you see as an exponent, can be reduced as well? So this would be 4a. What's 8 divided by 4? That's right, 2. So this would be the most simplified version of that number. We're at the lesson check. Please work through these and bring any questions you have to class tomorrow.